Hello dear students. In this video, we will be working on the proof of Basic Proportionality Theorem BPT or Thales Theorem. After watching this video, you are expected to list out the prerequisites to prove Thales Theorem, write the statement of BPT or Thales Theorem, and prove BPT or Thales Theorem. In order to prove the theorem, we will be needing some prerequisites. So let's have a look at the prerequisites that we will need to prove the theorem. First and foremost, we need area of triangle, the concept of area of triangle, which we all know is half into base into height. Considering this acute angle triangle ABC here, the base and height can be determined in three different ways. First and foremost, let's consider BC to be our base. In this case, the perpendicular or height will drop from its opposite vertex, that is vertex A. So let's say AD is perpendicular over BC. In this case, area of triangle ABC will equal to half into BC into AD. Similarly, if we will change our base to AB, in this case, the opposite vertex is vertex C. So the perpendicular will drop from vertex C. So let's say the perpendicular is CE in this case. CE is perpendicular on AB. In this case, area of triangle ABC is equals to half into AB into CE. Finally, we can consider the base of the triangle to be AC as well. In this case, the opposite vertex is vertex B, so the perpendicular will drop from B. So let's say the perpendicular over AC is BF. BF is perpendicular on AC. In this case, area of triangle ABC equals to half into AC into BF. Drawing perpendicular over a triangle in case of a right angle triangle or an acute angle triangle is not a problem. But what if we have an obtuse angle triangle? So here we have an obtuse angle triangle where angle B is obtuse angled. Now, if we will consider BC to be our base, drawing perpendicular from the opposite vertex A within the triangle is not possible. So in case of an obtuse angle triangle, the perpendicular will drop on the extended base. So let's extend our base BC and then we will draw our perpendicular, let's say AD over BC. So the perpendicular in an obtuse angle triangle has been drawn on the extended base. Now area of ABC equals to half into BC into AD. The thing that you have to take care of here is the perpendicular has been drawn on the extended base. Another prerequisite for proving the theorem is triangles lying on the same base and between the same parallel are equal in area. Remember, this assertion has already been proved in grade 9. Here we have a set of parallel lines L parallel to M. Now let's draw triangles over this parallel. Triangle ABC and triangle ABD. They have the same base AB and the triangles have been drawn over the same parallel L parallel to M. In the figure we have triangle ABC and triangle ABD lying on the same base AB and between the same parallel L parallel to M. So we will have area of triangle ABC equals to area of triangle ABD. Now let's work on the proof of Thales Theorem or Basic Proportionality Theorem BPT. We'll start with the statement of the theorem. The statement is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. To begin with, let's consider a triangle ABC. Now we need to draw a line parallel to any one side of the triangle ABC. we are drawing DE parallel to BC. Remember, we could have drawn a line parallel to side AB or a line parallel to side AC as well. Now let's write the given part. We were given triangle ABC and a line DE parallel to BC intersecting AB at point D and AC at point E. Now, the line segment DE, which is parallel to BC, is dividing the other two sides into two parts. DE is dividing AB into two parts as AD and DB, and AC into two parts as AE and EC. We need to prove that the ratio of these parts are equal. So we need to prove AD by DB equals to AE by EC. Now we need to find these sides in some triangle. Side AD and AE can be found inside triangle ADE. Side DB and EC, they are not inside any triangle. So now we will have to do construction in order to put these sides inside some triangle. So we will join DC and BE. So on joining DC and BE, we have side DB inside triangle DBE and side EC inside triangle DCE. In order to relate these sides using area of triangle, we need perpendicular or height as well. Over here in AE and EC, E is the common point, so we will draw a perpendicular from E, and on the other side in AD and DB, D is the common point, so we will draw perpendicular from point D. So we will draw EN, let's say EN, perpendicular to AB, and from D, DM perpendicular to AC. So now we have the perpendiculars as well. This is the thing that we need to prove, so let's keep it in one side. Now, since area of triangle equals to half into base into height, the first side that we need is AD. So AD is in triangle ADE. So if we'll consider AD to be our base, the perpendicular or height for this will be EN. So area of triangle ADE equals to half into AD into EN. Now the next side that we need to shift our focus to is side DB, which is in the denominator of the left hand side of the assertion that we need to prove. Considering DB to be base of triangle DBE, which is an obtuse angled triangle where angle D is obtuse angled. So the perpendicular of this particular triangle will be drawn on the extended base. So the perpendicular EN has been drawn on the extended base, which is DB. So here for triangle DBE, the base is DB and the perpendicular is EN, which has been drawn on the extended base. So area of DBE equals to half into DB into EN. Now let's divide area of ADE by area of DBE, which will equal to half into AD into EN by half into DB into EN. Cancelling out the common factors, first half, half, then EN, EN. So we got area of ADE by area of DBE equals to AD by DB. So we have got the left hand side of the assertion. So let's give this as equation number 1. Now similarly, let's proceed towards the right hand side. On the right hand side, the first side that we need to focus on is side AE. Considering AE to be the base of triangle ADE, the perpendicular will come from the opposite vertex, that is D. So DM will be the perpendicular. So area of ADE equals to half into AE into DM. Now the last side that remains is EC. So considering EC to be the base of triangle DCE, which is again an obtuse angled triangle, where angle E is obtuse angled. So the perpendicular will drop on the extended base. So here EC is the base and the perpendicular DM has been drawn on the extended base. So area of DCE equals to half into EC into DM. Now dividing area of ADE by area of DCE, we have half into AE into DM divided by half into EC into DM. Cancelling out the common factors, first half, half, and then DM, DM. So we have area of ADE by area of DCE equals to AE by EC. Let's keep this as equation number 2. Remember, this was our equation number 1. So now, finally, we need to prove that the quantities that are there in the right hand side of the two equations, equation 1 and equation 2, are equal. That is, AD by DB equals to AE by EC. On the left hand side of the two equations, we have area of ADE by area of DBE in equation 1 and area of ADE by area of DCE in equation number 2. Now the numerators, there's no problem with the numerator, both are area of ADE. So now in the denominator we have two different triangles and their area of DBE and area of DCE. So if we can prove that the area of these two triangles are equal, then the left hand side is going to be equal. So which automatically equates that the right hand side of the two equations will also be equal. So our focus now has to shift on the triangle DBE and triangle DCE. Here, triangle DBE and triangle DCE, they lie on the same base DE and between the same parallel DE parallel to BC. Remember, DE and BC, they are parallel. It was given to us in the question itself, in the statement itself. So we will have area of DBE equals to area of DCE. Let's put this as equation number 3. Now, on comparing equation 1, 2 and 3, the left hand side of equation 1 and 2 will be equal. The numerators were already equal, area of ADE and area of ADE, and the denominators, area of DBE and area of DCE, are now proven equal with equation 3. So the left hand sides of equation 1 and 2 are equal. That means the right hand side also has to be equal. So AD by DB, right hand side of equation 1, equals to AE by EC, the right hand side of equation 2. Hence, the result has been proved. Now, work on the derivation on your own, and if there are any problems, let's discuss. Thank you and have a nice day.